American-made cadmium telluride PV is one of the few technologies that can compete with Chinese silicon on a per-watt basis. It represents about 5% of the total market, with the majority of CadTel PV being manufactured by rapidly scaling US-held companies like First Solar and Toledo Solar. With a small boost, CadTel PV can become an even larger player in the PV market. One of the outstanding problems limiting the efficiency of CadTel is the formation of a suitable back contact, the layer responsible for collecting the light-generated electricity and moving it into the connecting wires from where it will go on to do useful work. The back contacts currently used in industry suffer from inefficient electronic and chemical properties that reduce the ability to collect generated electricity. In addition, their high fabrication cost has an outsized impact on panel price.
New back contact materials are always of interest to us, not to mention the fact that they're labor intensive and they're fairly expensive.
This challenge is where our team at NanoSpray saw our opportunity to make an impact. Using innovative nanomaterial inks and inexpensive solution processing methods, we have developed high-efficiency back contacts, offering a path to both lower production costs and improved device efficiencies. NanoSpray aims to be essential to the supply chain of the rapidly growing CadTel manufacturing sector. With the funds from this prize, and from future SBIRs targeting scale-up, we will deploy a manufacturing facility in close proximity to key industry players, providing the raw nanomaterials to make high-efficiency contacts. You might not see the name NanoSpray on a panel anytime soon, but we'll be in the background, helping to bring low-cost solar manufacturing back to the US. By using high-throughput solution processing techniques, panel production rate can be increased, lowering the relative labor cost associated with each panel. Better electronics at the back interface allow the active layer to be thinned, reducing panel material costs. In addition, removal of the detrimental Schottky barrier would allow for improved efficiencies to be reached. Using a combination of publicly available data from First Solar's Series 6 module and information we collected from Toledo Solar's 100-watt panel, we estimate that our contact would yield 1.6 cents per watt in direct cost savings on back contact fabrication. Accounting for a thinner active layer and the small boost in efficiency made possible by this contact, manufacturers can expect an additional 5.5 cents per watt gain. With an estimated 10 gigawatts of production expected to come online by the end of the year, this translates to an addressable market opportunity of more than $700 million annually. Raw material costs for NanoSpray inks are very low, and our price target for our product reflects that. Based on the size of our market and the value our technology brings, we estimate that our company stands to generate around $500 million in annual revenue from supplying the two largest US CadTel manufacturers alone. However, by thinning the NanoSpray contact, we can also make transparent conductive contacts, which, with a little improvement, could enable new use cases for CadTel, such as bifacial, building integrated, and tandem PV, growing high-premium markets for solar. These transparent contacts could also be a disruptive technology for early-stage perovskite and organic PV companies, markets expected to grow rapidly in the next decade. Our proposed voucher-funded collaboration with NREL centers on the development of this future transparent product. At the beginning of the American-made Solar Prize, we had an idea and a few grams of innovative nanomaterials. Now, a year later, our company has made hundreds of test devices to nail down our optimal process and ink formulation. Then, we scaled high-efficiency prototypes with our partner, Toledo Solar. Our champion devices operated around 17% efficiency, compared with a 19% efficiency for a gold contact on the same panels. Here we use gold as a high-efficiency but prohibitively expensive control to check how much power we should expect to get out of a given device. We've also made 4-inch by 4-inch mini modules fresh off of Toledo Solar's production line. However, these devices operate at about 20% of the capacity of their gold counterparts. We expect that the discrepancy between our high-efficiency dot cells and our modules can be reduced by optimizing the interconnection through the P2 scribe, something that we will target during our collaboration with NREL. Long-term stability testing is ongoing, but our preliminary results show that the back contact is stable. We still have many levers to pull in optimizing our highly tunable nanomaterial inks, and we expect further performance improvement as our company grows and develops. We've also demonstrated semi-transparent devices using a thin CadTel layer with an efficiency of 8%, paving the way for NanoSpray's Contact 2.0. We also own the exclusive rights to a pending patent on the use of our technology. To bring our product to market, we need to show stakeholders that our contact is stable, efficient, and cost-effective. We are well on our way to doing just that. Our team, founded by 3 NYU researchers, has grown to include a new startup business development expert during the set phase. With our combined 30 years of experience in business and solar R&D, we are uniquely qualified to take on this challenge. Our board of industry and academic advisors gives our eager team a vast pool of experience to draw upon and positions us to rapidly scale and deliver on our vision for the future of the company. Through the competition, we've also made key connections with national labs, industry experts, and most importantly, our future customers, CadTel manufacturers. Here at NanoSpray, we think it's time the US regained its place at the forefront of PV manufacturing, and we are betting our innovative back contact can help get American CadTel to the front of the pack.